Hello, everyone. My name is Mingfei Cai, and I'm from the University of Tokyo. The paper I introduced today is simulating human mobility with agent-based modeling and particle filter following mobile spatial statistics. Nowadays, understanding daily human movement is important in the urban planning. Thanks to the wide use of the personal devices, disaggregated data can be collected for the analysis. However, even though disaggregated data are powerful, they are expensive, sensitive, or even unavailable for local areas. And it is difficult to share the research using such data in the community. As a result, our motivation is to realize low-cost and safe mobility reconstruction. To achieve that, we want to use data simulation to improve the agent-based model with low-cost and accessible data. Here is the outline of this study. First, we synthesize and initialize agents. Then we generate many particles with different parameter sets. And the agent model will decide behaviors of agents. Finally, we summarize all particles and generate final results. Here comes more details. For the agent model, first we assign moving patterns according to the national census. Then we use the multinomial logic model for the choices of destinations. Departure return time and transportation modes are decided according to the traffic census. In the particle filter, it uses many different particles to represent different possible states of the world. The real-time observation data are fed in to calculate the likelihood. The final result is generated by the weighted average sum of all particles. In the experiment, we chose Nanto City in Toyama Prefecture of Japan for the case study. We use multi-source data, including the open source census data and aggregated mesh data for the simulation. Here comes the result. This slide shows a violation of people movement. These two videos show the intercities and within-city trips. Here is a static analysis of population distribution. Figure on the left shows mesh population on the map. We can see that our model can find correct populated areas, and it tends to underestimate number of people. Figure on the right indicates the regression analysis for mesh population. In the early morning and late night, the correlation coefficient is around 0.8. Then in the rush hour, the core starts to decrease since the agent starts to move. The lowest point is around 0.7, which is satisfying. Here is the result of link traffic volume for the moving status. We show the absolute value and difference from the census in these two figures. Overestimation occurs for trips between the east and west of the city, as the comparison only includes the base roads. And other types of traffic, such as trunks, are not included. In conclusion, our agent-based model with particle filter can generate acceptable daily citywide trajectories considering several metrics. The limitation comes from the negation of contextual information, which capture complicated patterns. Further studies can focus on the derivation of more thorough iterative functions. And that is all for my presentation. Thank you.